Welcome to this maths lesson on enlargements. Previously, we've looked at how if you have a centre of enlargement, you can basically project from it through the shape and through with ray lines and create your enlarged shape. It's a bit like how a video projector would work. And we saw that if we had a scale factor of 1, we get exactly the same thing. Scale factor of 2, it doubles in size, but basically we go twice the distance. Instead of going along and up to A, we go twice the distance and twice up to get this new value of A. It talks about the advantages of and disadvantages of ray lines. We even looked at 0.5 and things like that, so when it's getting smaller and closer to the centre of enlargement. Let's just see what happens as we continue to decrease the scale factor. So we're approaching 1, it's getting closer and closer to 1. We get then below 1. What's going to happen when we get 0? Well, actually, it sort of disappears to nothing. Check this out. If we keep going, whoa, what just happened? Instead of it enlarging this way, it actually starts enlarging upside down in this way. And this is known as a negative enlargement. So we can have, for example, a scale factor of -2. And instead of it being up here on the top right, it actually ends up going through the centre of enlargement upside down over here. Okay, and -1 would be there, minus 0.5 would be there. Now, maybe you're thinking, why do that? Well, here's why. Because when you use a pinhole camera, for example, this is a pinhole camera, and this is an image of a discus thrower, ancient Greek discus thrower by the looks of it. The light goes into the camera and it actually goes upside down on the back of the camera, and you can take photos this way. And basically, we get a negative enlargement. We get some sort of shape. It goes through the centre of enlargement and it ends up upside down. If we return to this triangle, that is what has just happened. The triangle goes through the centre of enlargement and ends up upside down. This is also what happens when you are looking at something. So this is your eye. The statue goes into your eye. The light from it, that is. It projects onto a focal point inside your eye. I've forgotten some of the technical names, but yeah, it goes through the lens, it hits a focus, and then it actually carries on to the very back of your eye, but flips around and it hits the back of your eye where the retina is, and that information is processed. It goes to your brain. Your brain then actually flips that image around, so you're not walking around seeing things upside down. You're actually seeing them the right way. But it's scientific fact that if people get concussions and suddenly they start seeing things upside down because their brain's a bit confused and it hasn't managed to process things correctly, and you'll walk around seeing everything upside down for a short period until you manage to recover. So negative enlargements, very much a thing. They're not just making it up. They're used in pinhole cameras. They are used when you're looking at stuff. So right now you are looking at a screen. It's going into your eye, going negative enlargement upside down, back of your eye. Your brain then flips it around. Pretty amazing. And one guy who thinks this is even really, really amazing is Abelardo Morel, and he goes around taking images of these sorts of things. So this is actually a still photograph of a pinhole camera in action with a light bulb going through a pinhole camera, and then it's upside down. And he's also he goes around to hotel rooms as an artist. He basically puts black all around the room to absorb all the light, and puts a single pinhole into one of the pieces, like by the window, and then does a really long exposed photograph of what happens. And this is, I think, a New York skyline being projected through the pinhole onto the back wall upside down. So pretty good stuff. And just to summarize then, we've got centre of enlargements. When we have a positive enlargement, we basically go out from the center of enlargements through the shape. And if it's, say, scale factor 2, we go twice the distance. Twice the distance. If scale factor 3, we go 3 times the distance, and so on. But we start with rays from the point and we go out beyond the shape. When we have a negative enlargement, we actually start from the shape and we go through the point and then we just keep going. So in this case, it looks like it's a -2 scale factor. So instead of going B to O, we then would double that to go from O to B, and we end up with this flipping. So just be aware that it's nearly the same as previous with these positive scale factors, but instead of starting from the center of enlargement and going out, we start from the shape and go to the center of enlargement. Let's see it in action then. So enlarge object ABC from center 4, 3 by scale factor -1. Let's give this a go. All right, first things first. Now we're dealing with coordinates. I didn't do that previously, but I am now. So 4, 3 is going to be here. And what do? I don't go this way. I go from the shape towards the center of enlargement. Now, I'm going to do this again using both ray lines and by counting squares, but I really like to just start by counting squares, just prefer it. So if I start with A, I'm going to go along 2 and up 1. Because it's now a scale factor of -1, I don't double it or anything. I just go the same amount again, and I'm going to carry on going up 1, and then I'm going to go along 2 again. I don't change the direction, so I get this kind of thing. So A has gone to there. If we do the same for B, it would be along 6, and up 1. So I'm going to do the same again. I'm going to go up 1 and along 6. Like you could go along 6 and then up 1. I just sort of like to carry on the same way. Along 6, up 1, along 6. That's how I do it anyway. So it gets to there. It's a bit harder to guess where, or maybe you can see where the last point is going to be, but I'd say try not to rush it. Take your time with these negative enlargements. This last one, I'm going to go along 6 and down 1, and then carry on going down 1 and along 6, and it actually ends up here. And I've got my shape like so. It is flipped around. It's the same size, it's just I've done a negative enlargement about 4, 3. Now, what other kind of transformation could I use to obtain this new shape? Thinking back to ones we've done, not an enlargement, but one other one. What do you think? Well, it's not a translation, because it's facing the same way. It's not a reflection, because it would still have the base on the bottom. It's actually going to be a rotation of 180 degrees, although I don't think that point is correct. It's not going to be about 0, 0. It would actually be about this point here, 4, 3. And essentially, a negative enlargement by scale factor 1 will be equivalent to a rotation of 180 degrees about that center of enlargement. That will always be the case. I don't have it quite set up to do it right now on here, but if you checked with some tracing paper, you would see that it was the case, trust me. All right, that's the case for -1, but there's other ones we can do. So let's take a look. If you're feeling confident, have a go at this. Otherwise, I'm gonna go through it because it does get a bit technical and complicated. All right, 4, 3, same center of enlargement again. This time though, scale factor -2. So right, the minus means I start from the point and I go through the center of enlargement. So I'm going 6 and 1. But this time, because there's a 2 there, I'm going to double it. And I'm going to go down 2 instead of 1. And then how many am I going to go across? It's going to be double 6. It's going to be 12. I think it's that. Let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There. I think I'm going to label that point. That's going to be C prime, my new value for C. Let's do the same for A. This one's going to be a bit nicer because it's not quite as far. So I'm going to go along 2 and up 1. Right, I'm going to double that. So I'm going to go up 2 now and then along 4. And that is my new value, or my new A prime. Then after I take B, I'm going to go along 2, 3, 4, 5, 6 and up 1. So double that, I'm going to go up 2, and then it's going to be 12 again. 1, 2, 3, 4, all the way to here. And this is going to be B prime. I've got my new shape, I draw it in, it's flipped around. That is an enlargement by scale factor -2. Okay, same process before, but this time I was just doubling it. So remember, the negative means we start at the shape, go through the center of enlargement, we just sort of then keep going. When it's -2, I have to also double it. All right, this one, give this one a go. Pause the video, give this one a go, see if you can deal with -0.5. Well, it's going to be the same center of enlargement again. Okay, let's do A first. So along 2, up 1. I'm going to halve that this time. So actually it's going to be up a half and then along 1. It's going to end up here pretty much. That's going to be C prime. For B, I'm going to go along 6 and up 1. So halve both of those, it's going to be up a half and then along 3. Actually, it's quite hard to see, isn't it, from this? Let me draw in what I've got so far. So I've got this as my shape. It should be down slightly. In the exam, you probably would find that it would lie perfectly on the grid lines, but I'm doing it without in this case. Then the last one is C, so I'm going to go along 6 and down 1. So halve both of those, I'm going to go along a half, down a half, and then along 3, and it ends up there. Connect it, and I've got my shape. An enlargement by scale factor -1/2. Something I just realized I forgot to do was actually draw the ray lines in. So let's give that a go. If we draw the ray line through the center of enlargement, it should touch the corresponding point, and it does here. You can see how well it works. Okay, don't forget about the ray lines. They're going to come back in and be really useful. I think it'll work better for the other two. Center of enlargement. It's almost like you can connect it to the point and then you can just check that it goes through the center of enlargement rather than trying to make it go through the center of enlargement. Okay, but that all works brilliantly, and this one does as well. Okay, fantastic. All right, here is a task. This is actually a puzzle made by a previous student which tests this skill. Can you perform the following enlargements? Some of them are positive, some of them are negative, to try and work out what you get at the end. Pause the video, give this a go. All right, this is what happens. So you should get this smiley face through all your enlargements. And now, finally, we're going to put it all together. We've done translations, we've done reflections, we've done rotations, we've done enlargements with positive scale factors, and today we've done enlargements with negative scale factors. So I'm going to test you on all of these. Can you perform the follow? I'm going to, I remove coordinates, but we do have some vectors. We've got, some degrees. Can you have a go at doing all of the transformations and, different questions to try to fit this together into something? Just take each one in turn. if you're not confident, maybe leave some of them for later on. You could work your way down, or you could say, right, I'm going to do my translations first, and then I'm going to do my reflections. Up to you. But pause the video, give this a go. I'm going to show the answer in about 10 seconds time. Okay, this is what you should get. It does form a nice shape, super croc. So if you got that, you can be pretty confident at this point that you can perform all 4 of the transformations, including negative scale factors. Well done.